understanding, helpful, a listener, funny, kind, tries to be ethical for the most part, and intelligent. It sounds like the perfect partner. Or should I say, it sounds like ChatGPT. Have you ever spoken with a chatbot and thought, wow, like I'm in awe, I could be in love? Okay, that might just be me, but regardless, today we're going to lift the lid on these intelligent algorithms behind these digital know-it-alls. That's right, we're talking about large language models, or LLMs. They're like the valedictorians of the chatbot world, except they won't ask you to sign their yearbooks. Let's prep our brain cells because we're going to go through a wild ride through the circuits of ChatGPT. The heart of LLMs, much like our own brains, relies on networks, but instead of biological neurons, they use artificial neural networks. Picture this, a vast web. Each node or artificial neuron performs mathematical functions. These nodes, interconnected by edges, transmit and process data, imitating our brain's signal relays. LLMs are trained on massive data sets, billions of sentences from countless sources. They learn the intricacies of language by detecting patterns in all of this data. But here is where the true marvel lies. Using a technique called deep learning, these models layer their artificial neurons, allowing them to discern not just words, but context, tone, and even sarcasm. And suggesting the next word in your sentence or correcting your grammar, that's LLM, analyzing sequences that it's seen before, predicting like the most likely next word or phrase. And the key math magic is weighted sums. Each connection or edge in this web has a weight. When data enters, each neuron multiplies its input by this weight, and all of these products are then summed together. This is the weighted sum. If this weighted sum surpasses a specific threshold, the neuron fires and sends the information to the next layer. Imagine 10 friends whispering secrets in your ears. Not all whispers carry the same importance. You prioritize some over the others, right? And that's analogous to weighted sum in LLMs. This mathematical dance of weighing and summing helps LLMs predict your next word, correct your grammar, and so much more. But what happens when an LLM gets it wrong? That's when it enters backpropagation. Think of it as teaching a child to correct mistakes. First, you identify where the mistake happened, and that's the error, calculated as the difference between the LLM's predicted output and actual. Once we have this error, the next step is to figure out which neurons contributed most to it. And just like when solving a problem, we trace back our steps to see where we went wrong. Here's where the calculus comes in. Using derivatives, the model measures how sensitive the error is to slight changes in the weights. In other words, it asks, if I tweak this weight just a smidgen, how much will the error change? Based on the sensitivity, the weights are adjusted proportionally, and if a weight contributed heavily to the error, it gets a bigger nudge. If it's a minor contributor, it's tweaked just a bit. This way, over time, and with lots of data, the model becomes better and sharper in its predictions, continually minimizing the error. And it's iterative learning. Much like practicing a musical instrument, each iteration or practice session leads to fewer mistakes and a more harmonious output. LLMs aren't perfect. Constant refinement is the game, minimizing errors, understanding nuances, eliminating biases. LLMs revolutionize education, break language barriers, and redefine our digital interactions. Language learning models merge math, language, and technology to bring us closer in our global conversation. So let's keep talking.